Just in previous lectures, already we have learned the Loyal's algorithms. Already we have learned this concept. Loyal's algorithm is the very much popular and simply famous algorithm, famous approximation algorithms that we have used for the k-means clustering. Okay, but as always, there have some drawbacks also. Okay, now let's try to understand what kind of drawbacks it have. Okay, and let's try to remove how you will remove these things. So if you remember the in loyal theory algorithms, there are 4 steps. So the first step that we have assumed the initialization step, initialization stage, initialization, initialization. Okay, this is the first step. So what in this step, what are we doing? In this stage that we have to do, we have to pick the random points. So we have to pick, if we have taken the k as our hyperparameter, then we have chosen, we have randomly pick the k points randomly pick k points from the data set D. From the data set D, we will pick randomly we will pick a random point, first initialization stage. We will doing these jobs. Suppose let's take the picked point is C1, C2, C3 up to Ck. We will pick such kind of k points from the data set D. So this stage that we have applying here, this stage is called the random initialization. Random initialization stage is called the random initialization. Okay, but there have for this stage, in this stage, there have some problems. Now let's try to understand what is the problem on this stage. Problem. There have some problems on this stage. Now let's try to understand what is the problem actually on this stage. So the problem is the sensitivity of this initialization. So what is sensitivity? So the problem is initialization sensitivity. Now try to understand what is the sensitivity of this algorithm. Initialization sensitivity. So initialization sensitivity is, so the point we have picked. So sometimes we faced such kind of problem that we get different kind of clusters picking the random. Okay, that's kind of problem we have faced. So I think it will be better if we try to understand the sensitivity thing with an example. Okay, so the sensitivity, the drawback of this sensitivity is finite cluster and centroid. Final clusters and centroids. On this final stage, this is the main problem. Means on every stage we get various kind of clusters structure. Well, let's try to see these things through an example. This will be better for better understanding. Now let's try to understand this thing through this example. So in these examples, suppose let's try to understand this. So if you just see this picture, this is our original points, the data that we have. This is the original data set, the point that we have. So in human level, if you visualize this thing, so they have one cluster. If you ask a 5-year-old kid, yeah, some humans, they can easily detect this is one cluster, this is another cluster, this is the another cluster, this is the another cluster. Means this is the original clusters that in the data that we have. So after one initializations, the state that we got, suppose let's take we have one initializations, and after end of the our algorithms, Loyal's algorithms, after end of the Loyal's algorithm, suppose let's take we got this data set. So in one iterations, name for one initial randomization. I'm doing some explaining here. Randomization. So for one initializations, we got this cluster at the end of our algorithms. At the end of our algorithms, we got this picture. Okay, and suppose at initial stage, we have taken another random, because we have picked in the initial stage. We have to pick the random such k points, and the for if you since we picking the randomly h points, so it's equally probable to pick any point. So suppose let's take for one initializations, we got this cluster. That's okay. This one is okay. But suppose let's take we another cluster. In another initializations, we got this cluster. But just see these things. Here the clusters that we have find here 4 clusters instead of getting this cluster. Okay, this is the main problem here. So this or another initial randomization. We got this picture. This is the main problem of this Loyal's algorithm. Means initialization sensitivity. These things are the main problem here. Okay, now let's try to understand these things more visually. So this is the same data sets. So this is the same data sets D. So suppose let's take initially I have picked these 3 points. Means since to pick the h points are equally probable, suppose let's take initially I have picked this point, and this point. Okay, initially I have picked these 3 points. So by simple using using the Loyal's algorithms, at the end of the Loyal's algorithms, we will at the end of the iterations 1, we will find these are the clusters. We'll find these are the another cluster. We'll find this kind of 3 clusters. Okay, because based on these 3 centroids, we'll gather this point, make this cluster point. Okay, these are the after iterations 1, we will make this cluster, and after these iterations, we have to update the centroid for each cluster. So suppose let's take the centroid updated in these iterations is like here. For this cluster, the centroid will be like here. For this cluster, the centroid will be like here at iteration 2. The same things also for iteration 3. Now based on this centroid, we have to calculate its cluster based on this centroid. So based on this suppose let's take we will find this cluster. We will find these clusters. Similarly for here, and updated the next cluster. So at the end of some iterations, we will find that the centroids are not much changed. Just see these things. Just see this iteration 5 and 6. Just see this iteration from 5 and 6. The centroids are here. Similarly for here also, from here also, from here also. Just see these three centroids. These centroids are not much changed. So here centroids did not change. So if the centroids did not change, we can stop our algorithms. Okay, means it's our algorithms is now converged. We already seen this thing, so we can conclude that this is our centroid 1, this is our centroid 2, this is our centroid 3. Sorry, this is a cluster 1, cluster 2, cluster 3. Okay, so at the end of our convergence we can conclude that this is the main cluster. So this is look like our original cluster. This is the mainly look like original cluster. So there have some errors. It's okay, but it's okay, it's no problem. This kind of errors we have considered, that's not problem. But the main problem is here. After initialization stage we will find this kind of picture. Now let's try to see this thing, this picture, this initialization. So here the random initialization that we have taken here. Suppose let's take, we have the random initialization that we have taken this random point, this random point, this random point. In these initializations I have taken this random point, these three random points. Okay, so based on the three random points we make this is one cluster, this is one cluster, and this is one cluster. Based on this centroid point, based on these three random centroid points. Now after making the cluster we have to update the centroid value. So let's take in iteration 2 you will update the centroid values here, for here, and for here. Okay, the same things, the same continuous process we will doing. Okay, but just see these things at iterations 4 and 5. So at the iteration, at the end of these iterations, our centroid does not change much, does not change much. Okay, so centroids are not changed much. But so our algorithms now conclude that our algorithms is convergence. That means that if centroids does not change much means our algorithms are convergence, so it will make the stopped here. But the problem is here, just see the cluster, just see this cluster. At the end of our algorithms, this will make one cluster, this will make one cluster, and this will mean another cluster. But this is very different from our original one. Just see the original one. This is the original one, but this is the at the end of our algorithms we got this cluster. We got this cluster. Okay, this is very different from our original one. This is very different. This is very different from the original. This is the main problem. This is the main problem to our random initialization sensitivity. This is the main problem. Because of different initialization sensitivity, because of different initializations at the end of our algorithms, we will get different kind of cluster. This is the main problem of the Loyal's theorem. But the scientists, the mathematicians make some hacks, make some changes here to remove this problem. Now let's try to understand. Now let's see these things, how we will remove these things by using some simple mathematical tricks. Now let's see this thing. So we can remove this problem. By using simple two tricks. So let's first is the simple one. Just repeat the k means multiple times. with different initializations and try to see which one is the best one, best clusters among them, and pick that. Okay, so the first one, this is a simple trick. Okay, that's not. Repeat this case means algorithm. K means algorithm multiple times. With a different initialization. Okay, just repeat these things multiple times, depends. Then after implementation, then pick the best clustering based on pick the best cluster based on what already we have seen. Based on there have already we have seen there have various kind of the main base concept behind the k means is what means we are interest we have to smaller the intra-class distance and we have to make the larger inter-class distance based on this clustering thing. This is the primary concept at the beginning of the k means clustering. We have seen that this is the cracks of the whole k means whole k clustering algorithms. The thing is we have to make the we have to make we have to make the smaller intra cluster distance and make the larger we have to make the larger inter cluster distance. Okay, that is two things that we have to make. Based on these two distance, we have to pick the best clustering. What is the best cluster? This is the one simple technique. But the second that we are going to discuss, this is the one intelligent and most popular trick, and this is the most recent recent development of the k means, the Loyal's theorem that we have seen in previous lecture. This is the very old technique for approximation theory, but the trick that means k plus plus, k means plus plus, because we have called the k means plus plus because we have developed these things from the k means algorithms already. If you guys remember, we have the if you just remember the c plus plus means what, we have make some development from c to c plus plus, and here also we have make some development for k means to k means plus plus. K means plus plus. Because of that, we call these algorithms as k means plus plus algorithms. We have developed something here. We have make some development here. Because of these reasons, we call these things as a k means plus plus. Now let's try to understand what is this k means plus plus algorithms. What is this k means plus plus algorithm? What is this thing? So the k means plus plus term that we have make the development has the change at the random initialization step. That step, that means that we have simple develop the concept of the initialization. Everything is okay, just we have the initialization stage. That is the main problem. Initialization sensitivity, that is the main problem to our k-means algorithms. For our Loyal's algorithms, we have just developed this thing. We have just developed these initializations. Now let's see this thing. Let's see how we'll develop this thing. So the instead of the random initializations here, instead of using the random initialization, we will use here some probabilistic based initializations. Probabilistic based means that you can call the smart kind of initialization. Smart kind of initialization that we have made here. So let's see this thing step by step. So the initializations, the first thing that here we have to pick the k random points. So in random initializations, randomly we pick k such random points for the k means algorithms. We have picked the, but the main difference here is, so let's try to understand. First step that we have to make, pick. We have to pick the first centroid randomly. Instead of taking the k such random value, we will pick single random point. So pick the first centroid randomly. Suppose let's take the first centroid that we pick randomly. We call it C1. Okay, from the data set D, we will pick this thing. From the main original data set, we will pick this random point from this data set. From this data set D, we will pick first, instead of here in initialization, we will pick random 3 point. Randomly we will pick the 3 point. Here actually k is equals to 3. So here instead of 3, we will pick just one single point. Okay, that is the first thing that you have to picked up. Now let's see in second stage what we have to make. In second stage, now for all xi, for all xi from the data set D, from all xi, we have to make some distributions. We have to make write these things. Have to make some distribution distributions for picking up the next centroids. Now let's see this thing. How we'll make this distribution? This is the main trick part here. How we'll make these distributions? So here we will pick the random distributions, means it is uniformly distributed. To pick h points is equally probable, but the thing that we have make change to here in this stage. Okay, this is the first thing. So let's try to see, just try to digest this thing, how we're doing this job. So let's try to understand and through pictures. So suppose let's take this. These are the data sets that we have. These are the data sets. These are the two kind of data. These are the data sets we have. So first we will pick here a random point. Suppose let's take, we will pick here a random point, this one pick randomly. We will pick this point and we will call this thing C1. First, this is our first centroid that we have picked randomly anywhere from here. Suppose let's take, we will pick this thing. Now after picking this, we have to make the distance from this point to make another points. We have to make the distance. So just try to visualize these things through table. This is the table. Here we have the xi. This xi actually, this xi this xi is not is equals to initial random point c1. These are the different from the that we have picked initially point, different point. Okay, and the next column that we have to take the distance square. In this column, distance square from the xi to the from the xi point to the rest of the means xi to our c1. That's the thing, c1. I think you will understand. C1 means the point that we have make here, that we have take here. It's the distance square. So first, suppose let's take the first point is, suppose let's take x1, x2, x3. Suppose let's take we have xn. Now we'll calculate it. Suppose let's take it's x1. X1 we make its distance. Suppose let's take distance square. Just I'm talking about distance square. Suppose let's take this distance square is d1, d1, d1 square. Okay. No, don't be confused. D1. Just distance square is d1. Let's take d1. From the another point we have to make the distance. Suppose let's take we have taken another point here. To make its distance, suppose let's take d2, d2, d3. Such kind of distance we have to make calculate. dn. Okay, this kind of n distance we will calculate it first. So, but the distances that we have calculated here by simply using this formula. Formula is norm of xi minus c1 whole square. By using this formula whole square, we have to make the calculated distance, and we have to remember these distance are different. These points are different from the initially picked point. Means these points, you can remember these things. This point, these all the points are d point c1, the d set. These are the set. From this set, we have to make the distance. Okay, now the distribution that we have make, the distributions, some distributions that we have make based on this distance, based on this, how will just say this thing, how will make this distribution. The distributions will be now pick a point from the data set d minus means this is different from the c with a probability proportional to the distances, proportional with the probability that are proportional to these distances. Okay, so the pick, now for next centroid we have to pick another point. So the probability to picking up this point, this probability value will be proportional to these distances, just if you write these things through mathematically, it will be like that. Push for next point, for next CIs. So let's take these next CIs. It will really probable for this dj's. Okay, this j value will be 1 2 to n. This I value, it will be 2 to k. Because already we have picked this c1 point, already we have picked this. Okay, just this formula we have to use to picking up. This is the simple distribution. This is the simple, these distributions we have to pick the next centroid. That's the simple mathematical hacks that we have to make. Okay, now try to digest these things through another example. Suppose let's take, we have 3 clusters of data. Such kind of data we have. This is one set, This is another class set of cluster. This is another cluster. Suppose let's take, if you just see these things, this is the three clusters, the three different type of clusters here. Suppose let's take, we will pick up one cluster point here from here. Suppose let's take, we will first randomly pick any value from this data. Suppose let's take, we'll pick this point, randomly picked this point, and we call this point as a C1. Now first thing that you have to make, we have to make the distance square from this point to the next of the rest of the points. So suppose let's take, we will make the distances from here to here, here to here, here to here, here to here, and here to here, here to here, here to here, here to here. Such kind of distances first we have to calculate. Now based on these distances, we have made a distribution that the picking up the next centroid will proportional to these distances value, because the distances from this point to these points are high, from this point to these points are high, so the picking of the next centroids must proportional to these regions or these regions, because these distances are high. Okay, so the next centroid that we have picked up, it will be these regions, but or these regions, because it is a probabilistic approach, because we make some probability based on this. So it is totally impossible, because the probability to picking up of these on these regions are low. Okay, since this is a probabilistic, because there may have some little chance, but the most of the chance lie on these regions or these regions. Okay, on these regions. So suppose let's take the next centroid that we have picked up. Suppose let's take, we have picked the next centroid here based on this, because the chances of picked up are mostly lie on these regions or on this region. Suppose let's take the next centroid that we have picked on these regions. Let's call to C2. And from the same things that you have to make, now you have to make the distances from here to here, here to here, here to here. These distances here to here, here to here, here to here, here to here, here to here. Have to calculate the edge distances, but the main thing, already we have picked this C1 as a centroid. Now we can remove this area, these regions for the next centroid, picking up the next centroid, because the next peak centroid are pick up mostly lie on this region, because we have already considered this, because we have already considered this is a centroid. This C1 as a centroid already we have considered, and by simple calculations we have make some distances formula. We have seen that these are the closer point from this centroid. So we will now, in the next iterations, we have neglect these points. Now for the picking of the next centroid, the calculation that we have make, the next highest value that we have. So the next highest value will be this region's point. Just see these things. Next, this region's point. Suppose let's take the next point that we have picked up here. Here is the C3. Okay. Now based on this centroid, we will make this cluster. That's the thing that we have to make here. Okay, that we have to make here. So I am repeating this thing. So just try to understand these things slowly. Just pause this video and try to understand yourself. Okay, I am repeating again this concept. Just try to clarify this concept first. Then it will be much better for you. So first we have to pick up any random value from our whole data set. Suppose let's take these are the whole data set D. Any random value that we have picked up. Suppose let's take, we have picked up C1 first. Now on the from the C1, we have to make the distances for the rest of the point. Now based on the distances, based on these distances, we have to make some distributions, and based on these distances, from these distributions we have picked up the next centroid value. Since the largest distances value will be the most probable to picked up, So the chances for picked up the next point will be lie on these regions or this region. Suppose let's take the next point that we have picked up from these regions, because it is a probabilistic approach. So there may be a chance from picked up here, but their chance is so lower. So but the distances from these regions to these regions are the much more from this point. So to picking up from the point from these regions are much more higher, or this region. Suppose let's take where the next point that you have picked from this region, from this region. Okay? So now in the picked up this point from these regions, now next step that we have to make, next we will calculated the distances, means we have to calculate the distances this is from this point to the rest of the points, but already we have taken this point, that point we have not considered, that point we have not considered. Okay, so now we have to pick the next distances, means these are the, but already we have picked up here, and we have from our tables we have find that these are the closest point from this centroid, so we have not considered this point. Okay, now we will pick this point and now calculated the distances from the rest of the point. Based on these distances we will pick the next point. Next, what will be the centroid? Now it will be the rest centroid, the next centroid. Now next centroid will be C3. Okay, just these things that we have to make. So the initialization state, that we will use to here the technique, we will try to pick up, we will trying to pick the points that are as far as possible, that are as far as possible from the other centroids. Other centroids means that are already picked up. That's the thing we have to remember. Picking up the point, try to pick up those points that are as far as possible from the other centroid, as far as the possible from the other centroid that already picked up. Okay, this is just these things we have to remember already for picking up the centroid. Now the question is, sir, why we will make some kind of probabilistic distributions? Why we will not use the distance, the farthest distance we will picked up? That's the more easy thing. Why will not this concept? Why will this the probabilistic concept? Okay, now let's try to understand this concept through an example. Now the questions that comes into our mind, why will choose, I will do this kind of probabilistic approach. I will do this. The thing that's coming to why we will do this probability. Why we will make this probability. Probability. Sorry for my bad. It's my bad. Probability. Why we make this probability? We can easily take this is a high based on the highest distance. Why we will not make this? We can make this thing. We can make this thing by simple pick a point. By simple pick a point. Pick a point which has the highest value of distance, which has the highest highest value of this distance. D square means distance square. I've used the which symbol, dist square. Okay. Which is the highest value of this distance square. Distance square from the point xi to the nearest centroids means I'm talking about nearest centroids. Why we have not picked a point that have the such kind of large distance? Suppose from this point to this other large. Why we have not picked this point as a centroid? Why we have make some kind of probabilistic distributions here? What is the reason behind it? Now let's try to understand through this example. Suppose let's take the data set that we have here like that. Like that the data and have some outliers also from this data. Suppose let's take this one outlier. As always, it's well, let's take here one outlier, here one outlier. Suppose let's take the outlier we have from our data. But the main problem is if you take the distances approaches. Suppose let's take first we have picked this point randomly as our centroid one, and we have made the distances from the rest of the point. If we make the distances, then you can see that these are the farthest distance. Now the second now after this after and based on these distances, if we take the deterministic approach, means the highest value from the distance square, then this value will be picked up for the next centroid. But these are the outliers of our data set. These are the outliers. These are the outliers of our data set. Outliers. So to remove the outliers, to avoid this concept, if we just remove, means this concept are totally deterministic. This concept are called the deterministic. Are called the deterministic approach. These are the deterministic approach. Okay, if you use this deterministic approach, then the k-means algorithms are more outlier prone. Okay, more outlier prone. So to avoid this outlier, to avoid these things, we will use this concept of the probabilistic concept, because here we will use the probabilistic concept. So this is the distance, far distance, this is also far distance, this points also far distance, these also far distance. So there may be chances to pick up any point on this point. But instead of, if you use the deterministic approach, then always our algorithms pick this point, the most farthest point from ever. But if we use the probabilistic approach, then it may be picked up this point, or maybe picked up this point, or picked. So if we use the probabilistic concept here, in such scenario, our algorithms are less outlier prone. Okay, because of this. So because if we use the probabilistic approach, then the algorithm is less outlier prone. Less outlier prone. But simple using this deterministic approach, then it is more outlier prone. more outlier phone. To avoid this outlier means to the algorithm that we have made to make this less outlier phone, we will use this probabilistic. I think you will got the idea. The main advantage of the k-means plus is the brilliant idea is here. So does not to remove so the k-means, the probabilistic approach that we have make the k-means plus plus to remove the to remove the effects of the outlier. To remove the effects by the outlier. Because of the only these reasons we make here the probabilistic approach instead of using the deterministic approach. Okay, I think from this video we will got some idea how what is the drawback of our k-mean algorithms and how we will remove this drawback by simple using this probability concept. Okay, I think you got the idea. I request you, please, if you till now, if you bored, feel the bored from this video, because I know this is very lengthy video. Just pause the video and revisit again. Okay, just revisit again from this k-means plus plus algorithms. How this and random initialization step has made. Okay, please revisit this from here. I think from these discussions you will got some kind got some concept how this picked up point, randomly picked up point, are doing to make the smartly choose the our how to choose the centroid, how to choose the smartly. Okay, so that's if you just revisit this thing concept step by step. Okay. So first thing that we have to make, we have to pick the centroid randomly. Pick one centroid. Pick the one centroid means pick the first centroid randomly from our whole data set. Instead of picking the whole centroids, CK, instead of picking the whole centroid C1, C2 up to CK, just we have to pick the first centroid, only C1, only C1. First you have to pick. Okay. Now first you have to pick up this centroid. Now we make the distances from the rest of the point to this distance to this centroid, and based on these distances we have to make a probability distribution that is proportional to these distances. Okay, and since the probability that we have made this is the proportional to the distances, we have chance to pick the next centroid that's from the further from the first centroid, from the first picked centroid. Okay, that's the first thing that we have to make. So after making this, we have to, by using these distributions, we have make the next centroid. The same things also for the rest one. Okay, and the one thing that we have to make, we have used the probability concept because to avoid this outlier concept. If we use the deterministic concept, then our algorithms are more prone to make the outlier as our centroid. So to remove this outlier concept, we use this probabilistic concept, because there may have chances to pick up this point, this point, this point. So just repeating these algorithms, we can remove this outlier from our centroids. Okay, this is the main concept of this k-means. I think the smart algorithms that we have discussed here, you will got some idea from. I request you, please revisit, please recap this video again. If you feel for bored, please pause this video and try to understand yourself. After making some break, just try to visit again and again.